Okay, welcome back. Like I said, we'll take a closer look at these storage policies and how we actually put them to use. And then we'll show specific examples in some upcoming lessons. So first things first, right? What is a storage policy? It's designed to control what type of storage is provided for your virtual machine based on which storage and also what data services or IO filters we would like to apply to the virtual machine. So the goals are for things such as categorize your data stores based on certain levels of service, and also be able to provision VM's disks on the appropriate storage. So with these storage policies, you're basically trying to capture your storage characteristics for things like your VM home files and the virtual disks and so on. In fact, you'll find that the VM's home files and the virtual disks don't all have to have the same exact policy either. You have a lot of flexibility as it relates to a VM with multiple virtual disks. So keep in mind, the way in which we set up storage policies, they're based on a set of rules. And the rules are which type of storage would we like to place our VMs in, hence a placement policy. And we can create rules that define what kind of data services we would like the VM to have applied to them. And so what we have are these two main categories. Now, I know we show three in our table, but basically you could divide these three items into two main categories. We have placement rules and we have data service rules. So the placement rules are part of understanding whether or not we have VASA supported storage or not. If you have VASA supported storage, we can learn from the vSphere side what capabilities each type of LUN and which type of storage has what kind of capabilities, right? We can learn from the VASA API what capabilities the storage has. And then by learning what those capabilities are, we can then choose which of those we would like to apply to a certain policy. These are what we call capability-based placement rules, right? They specify a particular storage requirement for the VM, which will guide your decision on the VM placement, right? This kind of helps you steer where you want the VM files to reside, right? So things that would apply in a capability set of policy of capability. A capability-based set of rules would imply you've got the RAID level defined in the storage, right? So if the storage can tell you what RAID levels it supports, right, it's learning that through the capabilities advertised through VASA. It may also provide the number of failures that the storage can tolerate. Meanwhile, if you don't have VASA capable storage, well, then you're going to have the vSphere team speak with the storage team far more frequently to kind of work through a whole set of storage options and where the common storage types fit in your environment. So maybe you have a whole collection of storage that fits the gold tier, and then you have another set of storage that fits the silver tier, and then you have another set of storage that fits a bronze tier. So what you'll do is you apply tags, right? We call this tag-based placement policies, where you basically, already have these data stores mapped out. You do this in advance. You go ahead and start organizing your data stores by their tier, by coordinating with the storage team, because you don't have anything advertised by the storage. This involves having to communicate with your storage team to learn what are all the different capabilities and then organizing them into tiers. However you want to label them is up to you. You could call them by the metals, like we have here, right? Gold, silver, and bronze. But you can also just call them tier 1, tier 2, tier 3. That's your choice, how you want to label them. That's your tag. You can decide how you want to do it. In fact, what you'll do is you'll probably create a tag category called storage tiers and then start creating the tags as part of that storage tier category. So you have a gold tier, silver tier, bronze tier, and so on. So that's your placement policies, right? And then you have data service rules, which are basically picking and choosing which of the 4 different data services you would like to apply in a particular policy. Do you want to have a policy that has something to do with encryption? Do you want to have a policy that has something to do with prioritization? Those are the built-in ones. Or you could have something like replication and caching as well. But keep in mind, these data service rules do not just define storage placement, but instead of how we're going to treat the IO as it passes through the ESXi host. So here we have an example. When you create a policy, that's actually what we're looking at here. You're in the policy rules definition screen. When you decide, I want to create a policy, this policy actually happens to be based on a storage provider. When you go ahead and create a policy, the wizard's going to ask you, well, what kind of storage provider are you going to build a policy against? If there is no storage provider, you're going to basically use tags. But if you have a storage provider, such as VASA, like we have here with this is the EMC Unity vVol. So it's going to provide us with a lot of information about that storage. This storage has different service levels. This storage has all kinds of different usage tags. It has IO limit options. It has drive type options. It has fast cache options. You name it. This VASA provided storage is advertising a whole lot of different capabilities. What we're doing here is we're deciding, okay, which of those features, which of those capabilities would we like to apply to this policy? So you basically are creating a restriction, a selection of a few of the items that are available in the storage so that we can now verify, okay, we've got all these requirements for this kind of workload. We then will find out, well, what storage has these capabilities, and the system will actually tell you, okay, well, that fits all these different kinds of data stores. Right? It'll show you, okay, these data stores are able to supply these capabilities. So then you can verify, are your VMs actually, if you apply this policy to a VM, you can verify, are the VMs on a storage that can fulfill that need. So it helps trying to organize and place your VMs based on your workload characteristics, especially in a large environment. So your policy also, as we mentioned, can be applied to not just the whole VM, but can also be applied at an individual disk level. Say, for instance, you have a VM that has a boot drive and it has a data drive or an app drive. You want to make sure that the VM in general has the silver policy maybe, but its application needs to be on gold storage. Well, that's very easy to do, right? So maybe that silver storage is going to be on a hybrid array where the silver storage is going to be on magnetic storage, where the gold tag or the gold policy based disk is actually going to be on all flash storage. So you can mix this up. You don't have to have one VM built with just one policy. Now, the other side of policies are these things called the data service or the IO filter part of a policy, right? Whenever an IO is passing through the ESX server, we can define whether or not the VM is going to be filtered in any way, right? Are we going to add replication, encryption, caching, or storage out of control prioritization? Do we want any one of those to go along with a virtual machine? What we do here is before you actually assign a policy to a VM, we create in advance what are called storage policy components. These components are basically the different IO filters. So you know what? vSphere already has 4 built-in storage policy components. There's one for encryption, and then there's 3 that are part of storage IO control, because we basically classify storage IO control in 3 different levels of prioritization: high, normal, and low. So you already have 4 built-in storage policy components. Components are handy because you create them in advance and you basically have them so you can use them and reuse them for different kinds of policies. So for instance, what if I had 3 placement policies? I have a placement policy called high performance. I have another placement policy called standard performance, and I have a lower placement policy called basic performance. So all 3 of those are determining the placement of our virtual machine. So maybe the high performance VM needs a relatency of no more than 15 milliseconds. It must be on SSD storage. Where standard performance, that's got a relatency limit of 25 milliseconds, and it has disk type should be hybrid, right? Where we don't really care whether it's magnetic or flash. And basically the policy is lenient in that case. Where with a basic performance policy, we're saying here the VMs can't have more than 50 milliseconds latency, and they're going to be on magnetic storage. So you have your different tiers of placement. Now, we've also decided, well, while we might as well give a VM, if we're going to give a VM high performance placement policy, let's also give them high prioritization as the IO is going through the ESX server. So we could create in advance different storage policy components that define different levels of prioritization. Now, they're actually already there. There's 3 already built in. There's one called high IO shares allocation, which basically gives VMs high priority. And then you have the normal IO shares allocation, which is kind of the default for everything. And then there's actually a low shares allocation for having even lower priority. But what's cool is that you can mix this up. You can find however you want to make this work in your environment. And so here we're deciding, okay, we're going to give high IO shares allocations storage policy component to the high performance storage policy. So it's going to place the VMs in high performing storage, and it's going to have high priority as it passes through the ESXi server. Meanwhile, for standard performance policy and for the basic performance policy, these both can have the normal IO shares, IO allocation storage policy component assigned to it, so that it has, at least these two have equal footing in terms of prioritizing their IO as they pass through the ESXi server. Now you can actually just assign a storage policy component without having a placement policy. And you can have a placement policy that doesn't have a storage policy component to it. And of course, you can have both like we have here. Those components are easily used and reused through different policies. So again, just to kind of make sure we get all this sorted out with what we just discussed, we've got our two main types of policies, and they're going to be based on placement, they're going to be based on data services, and we just want to make sure we get all that straight. So here's our big true-false question. Data service rules are used to help storage policy-based management place our VMs in proper storage. So are data service rules anything to do with placement policies? That's true or false? That actually is false. This is data service rules are how we treat the I/O as it passes through the ESXi server, which would include things such as caching or replication or I/O prioritization. Capability-based and tag-based placement rules are the placement policies, which we're actually going to show some examples in the next lesson. So that ends this overview of storage policy-based management, where we describe storage policy-based management in general and recognize the categories of storage policy rules. So we'll actually show how to actually create and build those policies using traditional storage in our next lesson. So stay tuned. I'll see you in the next lesson.